Okay, so we're just going to use the video today to sort of check on our ability to use the substitution method, which is what we practiced yesterday. So hopefully you were able to complete these for homework or during classwork yesterday, and some of you may have gotten a chance to check some of the ones on your green sheet and use substitution method on those. But remember, what substitution method is telling us is that if we have a system of equations, like this system up in part A, and we establish that y is definitely equal to some simple phrase, that these two things are equivalent, we can substitute whatever y is equal to for y in the other equation. So in this case, instead of writing 2y, I'll leave a little hole for myself, minus 5x equals 4. What can I substitute in for where that y was? I can substitute the thing the y was equal to. So then I could distribute. 2 times 3x would be 6x minus 5x equals 4. And I would end up with x equals 4. And then, this is something some people are still struggling with. How do you get the y from there? You don't need to set the equations equal to each other again. You can just take this x value that you got and plug it back and substitute it back into one of the equations for the x value. Obviously, the easiest equation to substitute it into would be that first one. So if y equals 3x, well, what do I substitute in for my x value? My 4. And I end up with y equals 12. And this is the most important thing that I really want to reiterate. When I'm asking you to check something with equations, what I mean is that you should take your x value and your y value and substitute them into the equations to see if it makes the equations true. So I'm going to use my other equation to check. So I know 2 times whatever my y value is minus 5 times whatever my x value was equals 4. And I'm going to substitute in. So my y value I was pretty sure was 12. My x value was 4. 2 times 12 is 24. Minus 5 times, oops, why did I write x there? I should 4 there. Minus 5 times 4 is 20. And 24 minus 20 equals 4. And 4 does equal 4. So the answer to this system I have to give as a point of intersection. Remember, you always put your x value first and then your y value. It would be 4, 12. Okay, let's try another one. Let's take a look at C. So in C, I have something that I could substitute in for x, right? X is set really nicely to this very small term, small expression. There we go. Expression is the word I'm looking for. So in my top equation, I'll leave some room to write something in for x plus 2y equals 18. And then what am I substituting in? Everything that x was equal to. So 3 minus y. So then I will distribute 6 minus 2y plus 2y equals 18. And if I combine like terms, minus 2y and plus 2y eliminate each other, and I end up with 6 equals 18. Well, 6 does not equal 18. So that means that there are no solutions to this equation. And what that means in terms of my graph would be that if I were to plot these lines, they would never cross. What would make them never cross? Being parallel. All right. So down here, when they're asking us to solve a system, or to not solve a system, but check and answer, we're going to do the same thing that we were doing up here to check. We're going to take our given values of x and y and put them into each equation. So 4 times whatever my x is, plus 3 times whatever my y is. Oops, keep doing that. Forgetting to leave my space. Equals 22. And I'm just going to check if that actually happens. Remember, in my point, 4, 2, this first number is my x. So that's what gets put in for my x value. The second number is my y. So that's what gets put in for my y value. It just happens that they put the x first and the y first here, but they might not have, and then I'd have to switch these. So 4 and 2. 4 times 4 is 16, plus 3 times 2 is 6. 16 plus 6 So that tells me that this point is definitely on this line. But in order to find out if it's actually the point of intersection, I also have to check the other rule. So I'm going to have x minus 2 times whatever my y was equals 0. And my x was 4. My y is 2. So I end up with 4 minus 2 times 2. And 0 does equal 0. So that point is also a solution to this line. Since it's a solution for both, that means that is the point where they cross. All right, let's get into today's activity.